DNS stands for Domain Name System. It's the system that allows us to use names instead of numbers when using network resources on a TCP/IP network. Although DNS can be set up to find resources on a private network or intranet, the main place where we see DNS in use is on the internet. Every computer connected directly to the internet needs a unique IP address. Human-readable IP addresses are made up of a string of decimal or hexadecimal numbers. It would be very difficult to find the information we need or send emails if we had to remember all the IP addresses of the resources we need to interact with. Like on our phones, for telephone numbers, we need an address book to look up IP addresses. It is also common for a single physical machine to host a number of resources. For example, a single physical server might be responsible for hosting a web server and FTP server. Our phone book analogy would have these as extensions on the main telephone number. DNS goes a little further than a phone book though, because it not only keeps our records so that we can find things, it also automatically looks up entries which we don't yet have. A good place to start is to look at what is known as a fully qualified domain name, such as www.example.com. Fully qualified means that it contains all the necessary information to be located on the network, which in this case is the internet. The .com is known as the top-level domain extension. TLD extensions are managed by the Internet Assigned Numbers Authority and fall into multiple categories. Geographic TLD extensions, such as .co.uk, are a common example of this, but there are many others such as .info, .org, or .io. The word example in www.example.com is the domain name itself. Finally, the www represents the subdomain. But how does DNS use the fully qualified domain name to locate individual resources? The process starts when a domain is registered with an approved registrar. The registration will need to have one or more name servers specified for DNS to work. These are known as authoritative name servers and hold the master DNS records for the domain. All other DNS servers will contain a copy of these records. There are several types of DNS record. The records which resolve IP addresses are known as A records. So example.com would have an A record pointing to the IP address of the server responsible for this domain. When you connect to the internet, the DNS details specified in your IP address setup are recursive DNS servers. Recursive DNS servers hold temporary copies of the DNS information for a domain and will resolve the IP address at this point if they have the information. Your client device may also hold DNS records, which can be temporary copies of those held at the authoritative name server or rigidly specified in a local file. Let's look at how we use DNS. We have just typed www.example.com into our web browser for the first time. The very first thing that happens is that our client machine will see if a local DNS record exists. If not, it will request the information from the recursive DNS server specified in your IP address configuration. If no DNS information exists, the recursive server will need to get the information for the domain. The DNS server will then perform what is known as an iterative query to other DNS servers, starting with the root server. If the root server does not have the information, it will respond with additional information to help find the authoritative server for the domain. This will likely start with the DNS server that holds all .com information. A second iterative query is then sent to the DNS server responsible for all .com domains, which again may not have the information, but does have information on the name server listed for example.com. This is the same server we set up in our domain registration. A further iterative query will then be made to the authoritative name server, which will respond with the DNS information for the domain. The recursive DNS server will then store a copy of the DNS records and pass the relevant information to the querying client. The local machine will display the web page at www.example.com and likely store a copy of the DNS records for future lookups. This video only covers the main parts of how DNS works. Local networks can have their own DNS servers, routers often cache DNS records, and there are other types of DNS record than those covered here. DNS is an important factor in setting up a network and simplifying access to the correct resources.